You ready to go?
Yeah, I'll start.
Okay, hold on just one second. Hey. Hi, I'm Art Fuel, coming at you from Open Networking Summit at the ConteXtream booth. Am I pronouncing that just right?
Yeah.
And Ariel here is going to show us a demo of the ConteXtream SDN solution.
Hi, I'm Ariel Noy. I'm a ConteXtream CTO, one of the founders. What I'll show you about a few words about our company. We are a carrier SDN company deployed in multiple tier 1 around the world. We established in 2007 and we are virtualizing the carrier network, and we do that with an SDN technology. So the challenge is to virtualize the network, to move from a physical network function to a virtual network function, to a load balance between the different network functions. What I present today is one of our solutions is over GI line services, where you have, after the run, you have a PGW, which is equivalent to a GGSN, or equivalent even to a fixed environment, some kind of a PRAS. After that, you have all kinds of services, which are becoming the GI LAN services. And each box you want to apply, you need to apply it as the maximum scale to all subscribers, and to put a load balance between every box, and to design it to the peak, and to have the redundant for each box, and apply it one by the others as a rails of boxes. And it's become a very expensive, while not all function gets to all subscribers. So you just want to select for every subscriber a different set of function based on what his profile is. So you want a different content filter for subscribers. Some do not want at all content filter. You want optimization just for the one that pay for optimization. And you want to apply it only for the cases that things are really needed. So today what you need to do is like put a box after the other, and it's a very expensive boxes and designed for the peak. While when you put ContextNet control into the game, which is after we apply ConteXtream, then you get for that only ContextNet is highly scalable, carrier grade, integrated with the network, and all the rest of the functions are being used only when they need to. Okay, so we are depending on the subscribers profile. We select the function, we load balance with them, and send it to that only when needed, only when they're available, and give them actually the 5 nines that they need to, while they are not. And we monitor them if they're available, and steer the traffic to them back and forth as needed, and the subscriber gets to the internet. So what we will present over here is a demonstration of that solution. We actually have over here the 3 laptops that will be part of the demo, and those 3 laptops are loaded with all the software that needed for showing that functionality. Just a few words about the situation of our company. So we already deployed this use case is already in 22 cities, 22 sites, over 50 cities, 50 million subscribers already deployed, a cumulative time of 9 years, 1,000 terabytes processed per day, and 160 gig daily peak download speed, over 13 billion header enrichment, so we put information in every HTTP get for about the subscribers, over 30 billion analytics records. So analytics is a big thing that we can generate part of the SDN. And we have also a few VNF of our own, which is like a TCP optimization. We improve the download speed by 40% in the LTE environment. So that's one of the use cases you will see part of the optimization part. This is another use case of IMS load balancing, which will be just another use case that we are handling. You will see that, you won't see that in the demo, but just to mention that we can virtualize additional services, not just the GI LAN services. So what we have over here in the demo, we have 3 laptops, and each one run on a KVM OpenStack and simulating the network. So we have, actually, skip slide. So we have a run emulation which connects us to a Wi-Fi, gets to the PGW, and we have a router that connects to the internet. Okay? In between, we select based on the subscriber selection, we select a different VM. So which VM that we have over here? We have a TCP optimization and header enrichments that provided by ConteXtream. We have a video optimization that's provided by Skyfire, our partners. And we have also additional VM, just we download from the internet, SquidGuard, which are not carrier grade. We just put them as additional VM, and they are not subscriber aware. And based on the subscriber, we send to them only when they are valuable. So that's how we just, with a very simple configuration of them, it's just, they are not subscriber aware, just a very static. They're becoming, we give them the subscriber aware and scalability and high availability. So that's the three laptops, each runs different VM. From the function that you will see, so the function that will show you a TCP optimization provided by ConteXtream, do a 30–40% download speed improvement in production, improve the user experience, video optimization provided by Skyfire, content filtering provided by just download from the internet, and header enrichment provided by ConteXtream. A few words about the flow of the demo. A new subscriber log in, will get to a CAFT portal, he do his registration, he will select the profile, and based on the profile will show you additional the VNF capabilities, the URL filtering, the TCP optimization, local, and YouTube. We'll try to do YouTube. I'm not sure that our show internet is good enough for that. And we'll show you, we'll try to do that. Okay? Remember, everything behind the scene is our ContextNet controller, which is a distributed federated controller that will change the OpenFlow rules in the different OpenFlow switches. So in each laptop, there is a Tor switch, okay, that our ContextNet controller will manage that rules on that Tor switch. Make sure that everything that's coming from the VM goes to that Tor switch. We just manipulate the neutron in the OpenStack to make sure that all traffic gets to the Tor switch, and our ContextNet controller manages that Tor switch. That we bring in VM in a Tor switch instead of a physical Tor switch because we didn't want to make all the noise in the show. Okay, so we can jump to the demo itself. So I will log in as the web donor over here. Subscribers logs in. I will select my profile. So let's start with a profile, which is no video optimization, no TCP optimization, no content filtering. Just a simple profile, just to get started, only get analytics. I do the submit. I get the OK. Okay? So you can see that the subscriber over here is getting that service. Okay? This is the web demo, getting that service, simple service, nothing in it. So he's a full subscriber, not getting an interesting service. If I jump to our GUI, sorry, okay, hit the refresh, and this is the subscribers. We can see whatever is surfing. So if I just go over here, surf somewhere, CNN, and you can see that subscriber is getting into CNN. I can also see over here his traffic. Okay, so I even can drill in, and I open up a Wireshark, and whatever he serves, all the information is being already can be presented. So what we do in production, we just select the IMSI of the subscribers, kick it in, and can see drill into only the traffic of that subscriber, even though on the pipe of the traffic can be millions of subscribers. So this is the ability to be subscriber aware inside the network, even if the environment is even after carrier grade NAT. So subscriber can be not just the source IP, sometimes it can be just port ranges in that source IP, which is make it much more complicated to understand which traffic belongs to which subscribers. And part of our analytics data is what we are showing is like whatever I surf, just click on the CNN, so the analytics data is already presented. And this is a very simple, very partial information of our analytic data. Analytic data is much more in-depth, like a number of bytes in, out, RTT time, access and network, number of packets drops. All the information is in there of our analytics data collection. So now we'll see this subscriber, what service he got. He will try to surf some video streams. So I go to that video streams, I'll select the movie, I'll click on the movie, I'll start it. This is a high quality movie, and in this run condition, not sure that he will be able to see the movie. So the movie sometimes stops. You can see that how fast there is no buffer over here, and the movie got stuck. Okay, now the client tried to buffer and grab the movie. You can see the mountains of traffic that is trying to download. Okay, so this is what happened when there is no additional optimization and the run condition is not allowing to see that level of quality of the movie. What I will do, I will change the profile of this subscriber. I'll select a different profile, which I hit the submit. And now I gave these subscribers additional services. I gave him a TCP optimization, I gave him a video optimization. You can see over here in the manager portal, like these subscribers got TCP optimization and video optimization, and this is his service. Okay? Now we can go and see again how the movie looks like. Okay? Now when he's got a better service. So I clicked on the same movie. Okay? And now you can see that the movie is being optimized. Okay? You can see that the amount of saving that happens in this movie, like how Skyfire squeezed that movie into a lower bit rate. Okay? So it's not looks as good as the previous, but it is running. It's running, and you can see the buffer is almost finished downloading. So, and you can see over here, open up the window, you can see the difference of the number of bytes that needed to download the previous, just partial, and now number of bytes that needs to download over here. Okay, so what we do in production, we have an integration with tools that monitor the run condition and tell us which subscribers is congested or not congested, and based on the policy we tell Skyfire on the get that if this subscriber needs to be optimized or not, and based on what is the condition of that subscriber. So only when it's needed it's being optimized, and not all the time. Now, so we talked a lot about the VNF and how we plug them in and out. Okay. Now I can show you what our ConteXtNet controller, which is a fabric distributed controller, is doing. Okay. So we can drill into the OpenFlow rules that we generate, and you can see over here the different rules that that we apply into the Tor switches. So there is some kind of a service that happens over here in this rack 3, Tor 3, and are additional in Tor 2 and Tor 1. Now I will apply additional service for these subscribers. Okay, I will go to the profile. You saw that this subscriber was surfing to CNN, And now I will put him under the child. Okay? I will change his profile to be a content filter with a child. I'll do the submit if you can just look on here. Okay? While I'm doing the submit, I'm changing the rules. Okay, the submit, okay. I changed the rule over here. Okay? So now there are more rules than what happens in before. Okay, you can see that the rules are changing based on the subscriber. So now this subscriber has a child service, and once I have to remove the cache. We'll open up the browser, and now when he's having when he has a child content filtering, so if he's trying to surf CNN, he's being redirected to Disney. Okay, so this is the content filtering that I apply for these subscribers. What I forgot to show you is our TCP optimization. Okay, I will just remove the content filtering. And we have a TCP optimization app, okay, which is doing the download speed improvement. This is part of the app. So if I hit the start, what we're doing is downloading with TCP optimization, without TCP optimization. There is ACL that doing difference optimize, non-optimize. So it happens so fast that you can see like optimize is less than a millisecond, 875 milliseconds, less than a second, and optimize was 1.5 seconds, so 76% of download speed. And since you can see the peaks, so if I select do it again, I'll select it with 5 meg, we may see a difference in the graph. So sometimes it happens, sometimes it's not. What we do in production is stable 40% download speed improvement. Over here it jumped to the roof, I don't know why. But it's better that it jumped to the roof to the positive instead of the negative. But you can see over here the difference that's happening. Okay, so optimize is high and non-optimized stays low because the run condition is slowing that down. So I forgot to show you where everything is running. Everything running on OpenStack. Okay, you can see the different OpenStacks. You can see all the VMs. They are on these 3 laptops, different VMs, and how much memory CPU has been allocated. I can go to the network topology, and this is the 3 Tor switches. They are the only one to connect it to the underlay, and we are doing a tunneling in the underlay, and everything, all VMs are connected to the 2 different networks, which is kind of towards the access, towards the network, and it simplified the VM, and the Tor switch is the next stop for this every site. I think I covered.
Well, that's very, very good. So that's, ConteXtream. They have, comprehensive SDN and NFV solutions. And one thing we didn't mention, so they already have this deployed in many live production networks, including one of the largest wireless providers in North America. And you mentioned Telenor is a publicly referenceable customer. So in production today. So great stuff. Thanks for your time.